Hi everyone, welcome back to the Northwind Developer for PowerApps series. I'm George Hepworth of Grover Park Consulting. If you've followed this channel, you know I've been replicating the Microsoft Access Northwind Developer template in PowerApps using SQL Server on the back end. In the process, I've moved most data operations and logic into the back end as stored procedures. You can check out previous videos for examples and explanations of why I did that. Today, I want to show you something new, a feature that brings PowerApps a little closer to the way we write and reuse logic in Access VBA. And this time the logic will be in the PowerApps interface. Microsoft recently moved a feature called User-Defined Functions into Preview. UDFs in PowerApps are similar to those you can create in other programming languages. The key difference between standard PowerApps named formulas and UDFs is that user-defined functions are parameterized, taking both input and output parameters. That means you can reuse them throughout your app. As Access developers, we rely on reusable functions. We don't like repeating the same formula 10 times across different forms. For example, the public function getString in the Access Northwind Developer template appears many times throughout the application. The code in it is reused with different parameters. In PowerApps, that's been harder to do until now. For example, the code behind the Save button generates the parameters for our stored procedure and then toggles the toggle button that fires the stored procedure. This has to be replicated individually behind every Save button. UDFs gives us modular logic in PowerApps. A huge improvement. It's not quite VBA, but it's a step in the right direction, and it saves time, improves clarity, and makes maintenance easier. If you've seen earlier videos, you know that the Northwind Developer for PowerApps application does things a little differently from most PowerApps applications. There are no bound forms because we're in the browser environment, and no direct connections to SQL Server tables or views. Instead, I use stored procedures for all CRUD operations and data validation. That means the app itself is lighter and more maintainable. And now, with named formula UDFs, the logic on the client side gets cleaner too. Let's look at 3 examples of named formulas I've implemented in Northwind PowerApps. First up, F currency. I've used color highlighting to identify the different components of a user-defined function, the UDF name, one or more input parameters along with their data types, the data type of the return value, and the calculation that returns that value. This one is simple. A wrapper to format numbers as US currency. It's adaptable for other currencies, for example, euros or pounds. Editing this UDF by replacing the currency symbol and the delimiters allows us to quickly change every currency displayed across the entire application. No copy-paste is required. Next up, we have a calculation for the extended price of a single line item. The same color highlighting identifies each component of this UDF. The name is F extended price. It takes 3 input parameters. All are numbers. It takes the unit value, the unit quantity, and discount if any is applied. It returns a number, which is the result of multiplying the unit value by the unit quantity times 1 minus the discount amount. That comes out of this UDF as a number. This works for both order line items and purchase order line items. That means we can use it at least 2 places across the app rather than copy, paste, and modify. You might already have noticed that we could use the previous UDF to wrap our extended price calculation and present it to the user as a dollar amount in US currency. Let's look at our final UDF. This one's a lot more complicated. I'll give you the high-level view of it here with the color highlighting to identify the parts, and then when we dive into the code, I'll show you in more detail how it all works. The name of the UDF is tax line item. It calculates the amount of tax applicable to each line item in either an order detail or a purchase order detail. It takes 5 input parameters: unit value, unit quantity, and discount, which we need in our extended price calculation. It also requires the tax status, which will be either tax exempt or taxable, and the business setting ID. The business setting ID allows us to look up the tax rate applicable to our current transaction. Now, we're ready to dive into the code. We're looking at the design environment for PowerApps. We find formulas under the App section under Formulas. I'll expand the formula bar here so you can see the 3 UDFs we just described. There's F currency, F extended price, and F tax line item. I've added comments to help you understand what each of these UDFs does. The first is simply a wrapper that goes around a value, a number, and returns it as a string with the proper currency symbol and delimiters. This will appear a total of 30 times throughout this application. That includes the definition here, so 29 usages. Calculating extended price is done for each line item in a transaction detail. It's also part of the totals calculation because UDFs do not support tables. Summing is done in the controls where it is used. I'll return to this point when we look at a usage example for this particular calculation. It accepts 3 input parameters and returns a calculation. And it works for both order details and purchase order details. The extended price requires unit value, unit quantity, and discount, if any. Returns a number, which can be formatted using F currency. Calculating the tax amount for each line item in a transaction detail is more complicated. It's required for totals calculations again because UDFs do not support tables. Summing is done in the controls where it is used. I will point out here where that's relevant. These are the data types we have available. Notice that table or record set or the equivalent is not available. And we'll do the same here. Again, table or record set is not an available option. Summing has to be done on record sets or tables in the control itself, not in the formula. The first step in our calculation returns the appropriate Northwind tax rate for customers or for vendors. We accomplish that by using the business setting ID to tell us whether we're looking at a vendor or a customer. We go to our system settings table. The F system setting table is another named formula. It is the result of using a stored procedure to pull the records from the system setting table in the database. One of those settings in the system setting table is the tax rate for customers, and another is the tax rate for vendors. We pass in the appropriate business setting ID to get back the rate we're looking for. Once we have that, we apply the tax status calculation. Tax status is defined as either 0 for tax exempt or 1 for taxable. There are other ways to get to the taxable, non-taxable status using conditional if, for example. This math is simple. If it's 0, you multiply the calculation by 0, returns 0. If you multiply the calculation by 1, it returns the calculation. And now we can use our extended price calculation to determine the extended price for that line. So we multiply the extended price times the tax rate times the tax status, and we end up with the tax amount for one line item on either a purchase order detail or an order detail. Here it is in action on the screen for a purchase order detail. There's the tax line item itself. We pass in the unit cost, the quantity, the discount if one is applied, the tax status of a vendor, and we're purchasing from vendors, so we want the tax status appropriate to vendors, and we want the tax rate appropriate to vendors. As a matter of fact, the tax status for vendors is always taxable. Whenever we purchase products on a purchase order, we pay tax on it. So that the vendor tax status is taxable or 1. In practical matter, we do not have discounts for our products, at least in this implementation of Northwind. So the default discount of 0 will always be used. This, however, because it is part of the calculation for an order, we do allow discounts to our customers. It's part of the calculation, so even though it is not used in the vendor side, it's a required parameter, 0. Tax line item calculation returns a value, and then we sum that value across each line item in the current purchase order, and we filter our list of all purchase orders by the purchase order ID for the current purchase order, sum each of those line items, and wrap it in the currency format. We can look at the same calculation in orders. I'll quickly hop over to the orders list, and from the order list I want to take this one. We'll pick the even number, 200. The tax amount we calculated as $42.20 because this company is taxable. Their tax status is taxable. Tax status is not selectable in the interface. I can't override the default tax status. That has an implication in how we do our calculation, though, and that's why I wanted to mention it. Let's take this out of run mode and look at the order total. The order total uses our extended price UDF to get the extended price for each of the line items. It then sums those individual extended prices for the entire order and wraps that in the currency. The tax amount uses the tax line item UDF. It gathers the same 5 input parameters we saw when we looked at PO details: price, quantity, discount, the default customer tax rate. That comes from our system setting table. For customers, the default customer tax rate is 0.085. Here's where the issue of whether or not we can override the default tax status of our customers comes into play in our calculation. I've set it up so that in future, If we enable the ability to override the default tax status, this control will determine whether this particular order is taxable or not taxable and calculate a tax amount if so. We sum it by gathering all the order detail lines and wrap it in our currency. As you can see, tax line item appears 3 times. Once, of course, is the definition in our app formulas, and it's used twice, once on each of the order and purchase order screens. Extended price appears 8 times in total. Once in the formula where it's created, once in the second formula where it's used as part of the tax amount, and then several times on the order and purchase order screens. As you can see, having named formulas set up as UDFs allows us to repeat logic in multiple places without having to do a copy and paste of specific calculations. What's the takeaway? I hope you agree. Named formulas and UDFs, or user-defined functions, begin to make PowerApps feel more like access. You write modular logic, just like a function or a sub, in a VBA module. No, they're not as powerful as full subs or functions yet. You can't loop or create aggregate functions. But for calculations and formatting, they're a major upgrade. And as we saw with tax amount, you can combine them with control level code to achieve pretty impressive results. They make PowerApps cleaner, more maintainable, and much more familiar to the Access developer and all of us. In this video, I showed you 3 examples of named formula UDFs, which I have implemented in my Northwest PowerApps demo app. These are now part of my standard toolkit, and I think they should be part of yours too. If you're an Access developer exploring PowerApps, this is one of those features that helps bridge the gap. Try it out. Start with your most repeated formula and turn it into a named formula UDF. Let me know how it goes. Thanks for watching. If this was helpful, give the video a like and subscribe to my channel. I'm George Hepworth, and I'll see you in the next one.